Hi there, and welcome to this lecture on process flow diagrams, equipment symbol representations. My name is Marina Miletich. Just so we become more familiar with these different pieces of equipment, I'd like to show you some examples of many of the symbol representations you'll see in a process flow diagram. Here's another group of process symbols you may have seen in a variety of applications. Can you guess what these are called? These are vessels, and they have the letter abbreviation V. Vessels usually represent accumulation tanks or flash tanks. However, vessels should not be confused with storage tanks. Vessels are process units, which means they have a process stream going through them and are not used for longer-term storage. These first two vessels are accumulators, also sometimes called accumulation tanks, surge tanks, or blowdown drums. These three symbols are common representations of flash tanks, which are also sometimes called single-stage vapor-liquid separators or knockout drums. Even though these symbols are very similar to one another, it's important to understand the difference between these two types of vessels. Accumulators are a type of very temporary storage tank designed to hold some volume of a process stream short-term before it's sent to another unit. These tanks are sometimes also used for overflow or to hold temporary volume surges. An example of an accumulator is a reflux drum, which holds liquid reflux after it comes out of the condenser and before it's sent back to the distillation column. Flash tanks, on the other hand, are a separation process unit, and they physically separate a homogeneous stream into vapor and liquid portions which have different compositions. Flash tanks are not splitters. They're actually single-stage distillation columns without a reboiler or condenser, and they separate components based on boiling point. You can always tell a separation unit from a simple tank vessel by the number of streams coming out of the unit. If there's one stream coming in and going out of the unit, you have an accumulator. If there's one stream going in and two or more streams coming out, then it's a separation unit. I want to show you some important characteristics to consider when using these symbols on a process flow diagram. These vessels are examples of vertical and horizontal accumulators. Vertical accumulators are used when you need a vessel that can hold a large amount of liquid and also has a small footprint. It's also used for vapor-liquid mixtures when you may need to vent or flare vapors. Horizontal tanks are typically used for smaller volumes, such as for holding and draining a reflux stream for a distillation column. In contrast, because flash tanks are single-stage distillation columns, and distillation requires a vertical tower, flash tanks will always be vertical, never horizontal. This is the generic symbol for a vapor-liquid separator, and these are more detailed representations of a single-stage vapor-liquid separator. This line in these more detailed symbols represents the tray in the flash unit, and this is the liquid downcomer. In terms of simulation software, this symbol is similar to the default flash tank used in ChemCAD, and this is the default in Aspen. And for the most part, these symbols accurately represent the shape of these vessels in real life. You've probably seen these symbols on a variety of diagrams. They're especially prevalent on piping and instrumentation diagrams. See if you can remember what these are. These are all valves, and on a process flow diagram, they're used to depressurize a liquid, gas, or vapor stream. Remember that there are probably more than 100 valves in any chemical process, and so including all of these on a process flow diagram would be cumbersome and distracting. So only valves which are used for lowering pressure are shown. Valves on diagrams almost always have a bow tie shape, though in some simulation software they can look like the shape of a regular outdoor faucet handle. The four most common types of valves used in large chemical processes are ball valves, gate valves, globe valves, and butterfly valves. And unfortunately, the bow tie shape doesn't really represent how any of them physically look. I recommend you search for and look at some pictures of valves used in industry to get an idea of the variety of configurations, shapes, and sizes. This is the most common and general symbol for a valve and can represent any of the four types I just mentioned. This symbol represents a manually controlled valve, This usually means that a person is varying the flow rate going through this valve by opening and closing it by hand, and is most likely using a globe or butterfly valve to do this. This symbol represents a control valve, which means it's not being controlled manually by a person. The flow rate is controlled by a feed back or feed forward loop, or some other control method. In this case, this is also most likely a globe or butterfly valve, since these are optimal to use for throttling or controlling flow. In contrast, ball and gate valves are designed only to be kept all the way open or all the way closed, and should not be used to control flow rate. Using these valves to vary flow rate will ultimately damage them. In terms of simulation software, this valve symbol is the one typically used in ChemCAD, and this is the typical valve used in Aspen. This is also a valve you can select in Aspen, though it tends to be somewhat cryptic because not everyone can recognize it. One of the reasons it's important to avoid using confusing symbols for valves is because valves are not labeled or included in an equipment summary table and do not have a letter abbreviation. Even though they signify depressurization on a process flow diagram, valves are typically considered ancillary equipment and not as important to label as, say, a pump, turbine, or compressor. These next symbols are ones you don't see frequently in a process flow diagram and are technically not required to be included. Do you know what these are? These are symbols for storage tanks, and they have the letter abbreviation TK. It's important to remember that these are not accumulators or surge tanks. Instead, these are typically used for the storage of raw materials, starting materials, or products. As a general rule of thumb, these should hold no more than 1 month's worth of material. You might see any one of these variations on a process flow diagram. You might notice that these symbols do accurately represent what storage tanks might look like in a plant.